this experiment, you need a laser. Any power would do, and you need a tape, a non-transparent tape. So for this experiment, all you need to do is take this tape, cut it into pieces, and try to stick it in front of this laser as you were trying to make a double slit. Alright, there you go. So this is what you're supposed to get. So as you can see, a double slit over here. The slit over here is small, but it doesn't matter how small. You can measure it, but I just eyeball this. So it depends on how you want to do it. So this is what we'll be using to conduct our experiment. Alright, you can see some dark and bright spot over there, showing that
keep on moving.
The laser can act as a wave. So this will be further explained in the next section.
Like this only.
Study this experiment, you need to know two principles of wave. That is diffraction and interference of wave. Diffraction is the spreading of wave when it is traveled through an opening of an obstacle. In this experiment, the light source will pass through two slits, hence there will be two spreading wave and interference of wave will be occur. When the interference of waves occur, the result of the wave will be added up and result the constructive and destructive interference. The constructive interference will produce the light region on the screen, and destructive interference will produce the dark region on the screen.
The young double-slit experiment involves a laser shooting beam of light particles called photons at the screen with the two parallel slits. If we mark all the spots where photons hit the wall, we should expect to see two strips to correspond with two slits. But instead, we can see an alternating pattern of light and dark bands. This is the characteristic of the behavior of waves that passes through both slits. Young double slit was conducted by British polymath Thomas Young if the photons are fired only one at a time, which suggests that photons is interfering with itself as if it passes through both slits at once. Physicists were so stunned that they decided to observe which slit the particle went through, and that's where the things get really weird. When scientists use a measuring device to observe the slit that each photon passed through, the interference pattern disappears and the photons start behaving like particles. Instead of the spectrum of light and dark bands, we see two bright bands, so light can display characteristics of both particles and wave, known as wave-particle duality. It appears that light decides to behaves as a wave when it's not being watched and acts like a particle when it's being measured. Physicist Richard Feynman famously said the young double-slit experiment is absolutely impossible to explain in classical way and has in it the heart of quantum mechanics.
Hey,